Okay, in this part we are going to deal with the how to calculate the discharges from a given river flow data, stage and velocities. So usually when we measure a river system, we have the river and we do the river cross-section. We divide them into small amounts of the lengths, and then in that particular length we measure the depths, and then we can use one of the meters to convert them to discharge, like the mean area meters and the mid area meters. So in any ways, we all know that the discharge is the area times velocity, which means from this data we have to come up with a discharge or the velocity. So first of all, we have this is our depth, and this is our depth, and this is the distance from the left bank or from the right bank. So we can see the plot of these two, distance versus depth. So if you have depth in y-axis and distance on the x-axis, and say insert and say this one to see the river cross-section, okay, and this can be, this is an inverted form. So if you want to change this, you just come here on this axis and right click, and then format axis and say in a reverse order, okay, values in reverse order. So here is what you have. Then this is you can use formats, quick formats. This is edge in meter, depth in meter, and this is depth in meter, then, and this is going to be the distance from left bank. From the right bank in meter. Okay. So this is your valley. So we can divide these river valleys into the several cross sections. Then for a single cross section we can take a velocity measurement, and velocity measurements can be taken at 0.6 or 0.2 d or 0.8 d. So usually at the banks of the rivers, this place and this one, we measure the flow velocities at 0.6 d, and for the central sections where you have a larger depths, you measure the velocities at 0.2 d from the surface and at 0.6 d from the surface. D represents the depth of your river at this particular point. So the first thing is you can find the area. So if you have to find the area, we have to calculate the B first. For the corner parts, we can calculate area with approximate with a triangular section, and for the mid sections we calculate the areas by using the trapezoidal approach. So first let's find B. So B at this particular point, B, which means at this particular point, at the starting point, we can consider it as 0, and but B at this point 1, which is 5 meters, this is 4 meters, so this is 5 meters. The width of this cross section at 5 meters is from this one to this one, so this is 4 and this is 5. So we can take this equals the current distance minus the previous one, okay, and then you can do the same, because 6 is the next section, and then 6 minus 5 is another B. So if you do the same for the rest, there is your base. And now at the end, you can you have the end is at the point where you have 26.5, that is at 0b, okay, you have 0 value there. Yeah, 0.65, this is correct, because at that point we have 0, yeah, we have 0, and then you have to calculate the area. So at this point it is there is no area is 0, and at this point it is considered to be a triangular section. So this is equal to 0.5 times the triangular section. This is your b multiplied by h. This is the depth. Then if you say equal to, so this is your value. Then you can calculate this part as a trapezoidal section, which is b the width, okay, multiplied by the d1 plus d2 over 2. Okay. So this goes as that's all up to this point. So we have zero area at this particular point, and this one is our area at this particular point. So now we can calculate the volume, sorry, the average velocity v in meter per second. So and the area is in meter square. Okay. So our b is in a meter, and so the velocity is 0.6 d and the corners. So the average velocity is the same as the 0.6 d velocity. So up to this point is that works. But at this point is we have 2-point velocity. So we take the average of the two. So 0.2 d velocity and 0.6 d velocity divided by 2 will give you the average velocity. Then you can calculate the rest. At this particular point is the velocities are the same as these ones. Okay, so you have to calculate them in that manner. Then now once you find the velocities and the area, if you multiply area times velocity q, then you will obtain discharge in meter cube per second. So this is equal to area multiplied by velocity. This is equal to this one. So if you want to find out the total discharge that is passing through a cross section, you have to take the summation. So if you take sum, and this value means it is the amount of discharge passing through your cross section at an instant time. Okay, so if you want to see the velocity distribution, you can take the distance from left banks or the right banks as the x-axis, and the velocity as the y-axis. Okay, and if you insert a graph and curve it like this, you can see the velocity distribution through the cross section. So at the corners we have zero velocities, and at the middle you have a very large velocity that reaches to 0.3 meter per second. And you can do the same if you want to see the amount of discharge passing through a cross section. So here is your distance from left bank, and here is your discharge, calculated discharge. And then you can say insert and see the curve. This is the discharge by volume. So at the center you have like more than 0.5 meter cube per second. So with that you can see the discharge distributions also. Okay, this is how we can calculate the discharges by using the midsection method. And the other thing we can see here is the area elevation curve, how to develop the area elevation curve. So usually this is the elevation, this is the area at a given stage. This is usually be computed by planimetry. So, and this is the respective storage values. So if you want to draw the area elevation curve, we can use simply read your volume and area with respect to certain elevation. You can first draw your area, your elevation as x, and your area as y. This is the first one. So plot this curve. This is what you have, and add another data over here. Okay, again, and add it with x as an elevation again, because the elevation is a common value for both storage and area. Then as a y value you have to input the storage, and then you can see both data here. So you have to change one y-axis in order to have the nice shape of the flow, the elevation, and the storage area curve. So right click on this axis, and then format axis. Then you go to values in reverse order for one. Okay, sorry, the you have to go to the axis option first, and you have to go to the format axis, and the primary, sorry, you have to select this one first, and make this one primary axis, and then this one should be format axis, and then values in reverse order. Then you can minimize this value, or you can fix the minimum value to be like 1000, for example. Then you will have your curve like this. So here is your curve, and you can have a quick layout. Okay. So this is the elevation area curve. This one is, you can see that here, and this one is the elevation volume curve. Okay, this is how we develop this one.